Hey everyone, just gonna do a couple of quick sound checks. Hello, hello. Okay, probably a bit low. How's everyone's week? Good? Not good? Hands up for good? Hands up for bad? Yeah. Hands up for somewhere in between? Yeah, okay. Haven't figured it out yet. Well, I hope you're doing well. Week 5 is a funny time of term in a way, isn't it? You know, you've kind of got this, how would you put it? You've got a little bit of space from week 7, usually not a ton to do in week 5, but also you're starting to get tired. That's the problem with week 5. You get a first few weeks of term free, right, in terms of energy, and then week 4 kind of zaps it out of you. And now you're sitting here, with iteration 2's just been released, obviously, earlier this week, and you've got a bunch of stuff to do before the end of week 7. Just so I know, for my benefit, how many people here saw the week 2 live lecture, the one on Tuesday? Hands up. Okay, and who hasn't seen it? Thank you. A very useful poll. We are going to cover a couple of things today. They are mostly around, it's a funny one because what we have with this topic is this one is not related to iteration 2 at all. It's all to do with iteration 3. I'm pretty sure that's also true for the next topic, though I haven't read through the 50-page project spec in detail, because the first lecture today is about exceptions, which is again a topic that's relevant for kind of like week 8 onwards, as well as labs and stuff going forward. And the second part of today is to talk about software design. And the software design part is important in general, but I don't know how heavily or aggressively it's assessed in, so I was just turning the aircon back on. I don't know how heavily it's assessed in iteration 2. I think in iteration 2 you do get marked on your code quality. So it should be really interesting, and you should be able to have some takeaways from the second part of today. So I'd probably still just try and do a little bit with it. It just kind of talks about how do we write some decent software. All right, well, let's get stuck into exceptions. So this is a pretty short topic. It's really about ways that we deal with errors. We're kind of going to chat through it in detail, obviously. It should be insightful because up until this point, the reason we're talking about this is because you probably haven't dealt much with exceptions. You might have with Python, because I imagine did a lot of you do Python in high school these days? Does that happen? Yeah. It's a very mixed reaction from that. Don't really know the state of the curriculum at all in high school, but some of you might have come across it, but you probably haven't thought about it in too much detail. So when it comes to dealing with errors, because errors are inevitable in your program, we need to find graceful ways of dealing with them, you know. Now, how do we deal with errors so far? Well, you might be writing a C program, you might be returning 0 or returning 1. In your project, you've been returning an object that contains an error key that has a value that's a string that describes the error. In other types of pieces of code that might get written, you might kill the program at a certain point, you know, like things go wrong during our coding. And what's easy to understand now that we understand static and dynamic verification is that often a lot of the errors that go wrong are dynamic that we're talking about, you know, like really simple errors, like say the course website or the Git run website where you get your marks from. Those websites rely on connecting to the CSE account. They rely on connecting to GitLab. They rely on talking to a database somewhere else, you know. There's lots of different services they work with, and at any given time, one of those services could be down. At any given time, someone could enter really bad input, for instance. We have to deal with those errors. So take the Git run website where you do the leaderboards and you can submit reruns. When you submit a rerun, the way the program's set up is like it has to plan for the fact that you might give it garbage. You might dump something in there that's completely useless. We ask for a number, for a merge request ID, but we see students all the time, they'll enter the number 1 billion just for fun, or the number -6 or something like that. So we need ways of gracefully dealing with all these inevitable problems that come up. The way we're going to talk about dealing with them is through the topic of exceptions. So first, let's think about how do we deal with problems generally. Well, here is a program, and this program's job is to read in an input from the user. It is to turn it into an integer, and then it is to try and square root it. And if there's a situation where a user's given us something that you can't square root, we want to crash the program, you know? We want to kind of kill it. That's like the easiest, most loose possible way you could do it. So if we go and, let's go and npm install in the lecture code for today. We're just going to run this piece of code. I'm going to pull it up on the right as well. It's called just crash. There it is. We'll see what happens. It's a fun little program to play with. It's in TypeScript, obviously, because it's got .ts. You'll see there's not really that many types in it except for number. Even if I got rid of number, it would still work. npm run ts node just crash. Just crash. Didn't I npm install? Did it fail? Did I miss it? Oh, maybe we don't have that package here. That's weird. I have no idea why that's not installed. Prompt sync. Prompt sync's a synchronous prompt library. It should run for us now. OK, please enter a number. What's a great number to square root? 9. We get 3. Run it again, 25. We get 5. Run it again with 4. We get 2. 2, we get, no, I hit enter there early. We get nan. 2, 1.4. And then what happens if I type in -5? It says error input less than 0, and it crashes. OK, so if we dissect the code for a second, when we call this function, it just tries to use math.pow on it to raise it to the power of 1/2, which is square root. However, if the input is less than 0, we error to the console some piece of text. Now, you might not have seen console.error before. Console.error is basically like console.log. Console.log sends things to standard out, which is a particular stream on the terminal. Console.error sends it to standard error. In general, they both come onto the terminal the same. So like you as a user don't often see the difference. But the only reason we might ever do that is because certain Unix programs are able to kind of separate that out. So if your program is ever being used by someone, that person could extract the errors and the not errors from your output separately. So that's why we might write something to console.error. And then I call process.exit1. Process is a global variable in the Node.js environment. It's kind of specific to Node and not so much JavaScript. So when you like load up the Node environment, which is an environment that can run a version of JavaScript, process is a global variable that exists there and has a lot of stuff on it. You might remember it from earlier in term with like argv examples, right? So it's got a lot of things floating around. It has a function on it called exit, which will kill the process instantly. So on the terminal here, what I'm doing is I'm telling the operating system I want to start up a process. The process is now kind of running permanently. It's in like a little while loop, just waiting for me to enter something. I enter -5, and it kills the process straight away, and the JavaScript code isn't running anymore. Now, that's a really interesting way to try and solve a problem. It's not very clean, though. There are problems with that kind of code. It kind of ends abruptly. We might not have opportunities to clean up. We don't know who's calling this. What if this is a lovely little square root function that's being called as part of a gigantic system? You know, like imagine your server. Imagine you import a square root library and someone passes in a negative number and your entire server just crashes and there's nothing you can do about it, right? Like it force exits. That's not a very clean way to deal with things. So we want to find different ways, and one of the ways we can do that is we can leverage JavaScript's use of exceptions. Many high-level languages have exceptions. Python has exceptions, Java has exceptions, C++ has exceptions. Frankly, any kind of procedural programming or object-oriented programming language I've ever seen, which isn't that many, I don't look that deeply, besides C, has seemed to have exceptions in it. So they're very common, and it's not a JavaScript-specific thing. The specific syntax that they use is a little bit different depending on the language, but this is a JavaScript example, and all we've really done here is we've replaced the console.error line and the process.exit line with this line, throw new error. Now, when you do this course at uni, you haven't really done much with like object-oriented design or code. That's kind of what 2511's about. So I won't go too deep into it, but we're essentially creating something here. This is like a way of saying I want to create a new object, if you will, right? This happens implicitly all the time when you code. Like when you say something like const name equals Hayden, you know, JavaScript's really good at making that look really simple. But what is actually happening there is there's this kind of hidden object that's created that contains lots of underlying characters, right? Because if you think about being a C programmer, all this stuff still is kind of C under the hood is a good way to think about it. So there's still character arrays and things that need to get malloced and things for that string to work. However, it's just hidden away from you. So when we see new error here, it's just kind of doing a similar thing. We're creating a bit of a magical abstraction thing. So this here is just an item, if you will. And then the throw part is the really important keyword. That's the one that kind of says there's a problem, right? So the throw keyword's the key one here. If I run it again, if I run exception1, the program, we will enter number 5, still works fine, but what happens if I enter -5? Now I get this big thing on the terminal. This looks nearly worse, doesn't it, at first glance? It's like before it just had a nice little like error inputs less than 0, but now we've got this gigantic mess coming out on the screen here. So what's actually happened here? It's an interesting question. This line has done quite a few things, obviously, but we want to take a step back and talk about exceptions broadly. Before we do that, though, what exactly are we looking at here? Does anyone want to tell me your best description of what you think we're staring at? Yep.
Well, so the uncaught exception was thrown back, I guess, until it reached, I'm not sure what is, I guess, the interpreter, I suppose, and the interpreter has exited there.
Yeah, that's pretty much on point. So like what we're actually looking at here is we're looking at a history of how our program ran. Sometimes we call it a stack trace typically. I don't think it's described here as a stack trace, but it's very confusing to read in some languages. Like for instance, there's a lot of random stuff here you might not recognize. Like it kind of makes sense, like you're like, okay, the program started by running TS node, which called some random stuff, 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 that eventually called my file exception1.ts. And then that one eventually called the square root function in my exception1.ts, you know? So there's a lot of cruff here that's to do with what's actually going on behind the scenes. But essentially, when you think about running code, and again, you kind of know this from C, you have your main function, it calls a function, it calls a function, it calls, like it just kind of ripples on like that. And your program's just a series of functions calling functions to some nth degree. It's the same way, you know, if I'm like, okay, I want to share some news, and I call you up, and then you call you up, and you call you up, and you call you up. At some point, what an exception is a person on that phone chain saying, oh my God, I have a serious problem. And they like pause, and they start basically calling the person up back in the order till it gets back to me, hoping that someone can deal with it, you know? Think of it like bad news in a family, you know? It's like if you have some bad news, everyone stops what they're doing, and you might call your mom, then your mom's like, I don't know what to do, so he calls the dad, and dad's like, I don't know what to do, and then they call their mum, and then, you know what I mean? Like, that's not how anything works in reality, of course, but it's like that until someone can help out. And what you're actually seeing here is the equivalent of you called everyone in the family and like no one has any idea what to do. So the program just ends. So when you throw an exception and you see this dump out on the terminal, it's actually the equivalent of what we saw before, where the program kind of just stops where it is. But the reason it stops is very different, because in the early example we had here, it stopped instantly. It just like halted in its tracks. Whereas in this example, what happened was the square root function was like, something's wrong, I need help. So it goes and says, who called me? Well, I was called by basically the main function that was, you know, the exception1 main code. Imagine this stuff here is like int main in C kind of thing, right? Except it's not. You know, it's like, hey, there's a problem. And then this main piece of code's like, okay, I don't know what to do with your problem. So then it throws it up to the next person, which happens to probably be the TS node library that actually ran your code. And it's like, I don't know what to do with it. And at some point, no one knows what to do with it. No one knows how to handle it or manage it. So the whole program just says, I'm out of here. That's what happens when you get those kinds of process ending errors come up on your terminal. Now, what is actually happening here is that an exception, by definition, is an action that disrupts the normal flow of your code. It's typically an error. An exception doesn't have to be an error. You could use exceptions to like throw anything and stuff. Like you can pretty much think of the throw keyword as like a halt and yell until someone deals with my problem keyword. It doesn't have to be an error, but like it's pretty much exclusively used as errors out in the real world. Exceptions exist to elegantly recover from errors, you know, because it's much better than, you know, just process.exit1. Yeah.
To be clear, does an exception always specifically refer to a completion?
Can you say that again? Does an
exception always specifically refer to a throw completion?
A throw complete? What do you mean by throw completion?
Completion of a function, like for a function, I guess, or not necessarily a function, but the exiting of a code block through a throw.
I guess so. Like the way I would describe it is that in this piece of code, this is just an object, this error, new error. When we call throw on it, we basically halt the code. That new error is now the exception that's been thrown, and it's just getting handed up to anyone who can deal with it.
So it's specifically whenever you have like a throw statement, that's what it is.
Yeah. So without a throw, you don't have an exception. So the throw is the keyword that triggers it. Now, disrupting the normal flow of code is actually a really important concept, because, like as we'll see, it makes how we reason with code a little bit different. So we say exceptions are a particular method of ensuring software safety. That makes sense because we're trying to handle misuse of programs, right? Like typically you'll see a piece of code, there'll be exceptions to check if something goes wrong. Is someone not connected to the internet? Did someone give it bad input? Did someone enter a username that was too long or a password that was too short? Things like that. JavaScript relies on exceptions for the majority of error handling typically, whereas there are other languages like C that don't have exceptions. Now, where this gets really interesting is that there are two different types of methodologies here, which is easier. It's like ask forgiveness, is it? What's the actual phrase? Ask forgiveness, not permission, something like that. Can't remember when I first heard that, it was like 10 years ago. But the idea being it's like you act and then you figure it out later. That's the concept of an exception. But what we do in C is a little bit different. And these things are really important to contrast because how you've been doing errors in your project so far is very C-like, you know? And the best way to explain what a C-like error throwing is it's basically a function that always returns something. It always gets to the end and returns something. It's just what it returns might represent an error or it might represent a good value. Yeah?
Hi, sorry, I jumped late. Just to clarify, are you saying that the throw error is an exception? Is that what you're saying?
Saying throw creates an exception.
Oh, okay.
Yeah, and then that exception has to be dealt with. So if we think about iteration 1, right? You've got your function admin auth register. And how are you doing that function? You are going to typically be having a few checks. You say, you know what, if email is, I'm just making up some up. If email is blank, I'm going to return error, no blank email. And then you might say, you know what, if password.length is less than 12 or whatever it is, I'm going to return error, can't be short password. And then at the end, if everything's okay, I might return auth user ID as 1. This is a C style of programming. The idea here, we're always returning something. It's just the something we return might represent bad things. Now, there are good and there are bad parts of this. I'll start with the bad parts to motivate you about exceptions. Some of the bad parts are you create ambiguous return types. Some of you might already notice this in iteration 2, if you're doing any TypeScript, is that you suddenly have a return type for a function that might be like a complicated object, or it could be a different kind of object with one key in it called error that's a string. You know, so the person handling it can't really just be told, you're going to get back this thing. They get told, you're going to get back this thing, or you might get back this thing. And then in other languages like C, this gets really tricky, because let's imagine in C, you know, you're saying, I've got a list, right? So you think C, I've got an array of 100 items. And that array, you say, well, I want to find out what index a particular element is in the array. So you might have a function that's like find index of, and you pass in a number like, you know, or a value, say, maybe I'll make it like a char star array. You pass in something like Hayden. I'm like, where's the Hayden string in that array? And then this function might return you what? It might return you a number, like it's index 3. So if I say like int value equals that, and then I printf value, I might get something like 3, because 3 is the index in the array. But what happens if it's not in the array? How does it communicate you that there's an exceptional circumstance here where it's just not there? Well, what's the classic one? It might return -1. You know, you've probably seen that before. And it's like, okay, but again, what we're doing here is the exact same thing. We're having to figure out how to represent a specific problem going wrong under the same kind of type. And this gets more complicated, for instance, if instead of, you know, let's imagine I'm actually searching, let's say I have an array of characters like that, and I actually say find value at index. Then I give it, say, I want to look at what's at index 3, right? And then you go, well, damn, so it might print out Hayden if Hayden's at index 3, but what happens if I give it like index 102? What's it going to return? Well, now it's going to return null, which is fine, because like it's a pointer, and any pointer can be null. But the problem is now you're starting to have to kind of figure out how to hack this semantic of something's gone wrong into a return type. So you can either kill the process, which is usually a terrible idea. It's only really ever reserved for like absolute catastrophes. You can try and mangle the return type to be something in certain circumstances, or you can throw an exception. Because what exceptions look like, essentially, if you will, if I could just simplify this, is that instead of returning different errors in your project, you might be saying throw new error, and that error might just look like this. That'd be using exceptions instead. Now, there's a couple of things about exceptions that we'll come back to, but I just want to probably touch on this for a second. So exceptions follow the principle of trying to seek forgiveness, not permission. It encourages you to assume something will work and then just have an exception handler deal with it. What I mean by that is that, because these aren't probably the best examples for it, let's take this code, the square root code, for a second. Maybe I have it here. Yeah, so with exceptions, it allows us to kind of create a situation where it's like, we know something might go wrong when we call the square root function. So what we're going to do instead of just like, well, we can just call it basically is the point. If we didn't know there was an exception, we might need to check it beforehand. We might need to check if the number's less than 0. But we don't need to do that because we know that we're basically going to go to the square root function and we're going to say, hey, I want you to check this thing. I want you to do this. I'm going to trust that you're going to do it. And if there's a problem, I think you'll yell back at me. And that's kind of a big conceptual difference. I'll probably just get to the code because I can see some of the eyes glossing over. So it's like, if we come back to this piece of code, it does throw an exception in the square root function. That makes sense. But what we're not doing, and the second part of exceptions that's so critical, is we're not handling the exception. The point of exceptions is not for someone to throw it and then crash the program. well, it's like you might as well just exit. The point of it is to throw it and have someone deal with it. So if we take that code, we can go and enhance the code in the second example here, and all you'll see is the bottom part's changed. And what's happened is I've introduced the second half of the syntax here, which is the try-catch block. So a try-catch block, and you've probably seen it around somewhere with your code, or code on the internet, is that what you put in a try block is essentially code that you're kind of cautious, superstitious, concerned, or aware, whatever you want to think about it, that it might throw an exception. So you know the square root function might fail because you don't know what someone's going to input. You don't know if they're going to input a negative number. If you're a really defensive C programmer, you might be like, well, number equals parse, parse int input. But then you're like, how does parse int work? Sorry, I'm jumping ahead. So like, let's say, yep, number's that. And then you say, well, if number is less than 0, I need to kind of like handle that case. Like you're always trying to like cautiously make sure what you pass into a function is right. Right? So that kind of defensive programming approach is when we call square root, we're 100% sure the input is good. So we have to do lots of checks. We'd have to do more checks too, because the parse int function, right? Like if we have a look at how it works, if you give it a string, it gives you an integer for it, or it gives you a not a number. Because we're like, man, what happens if someone runs my program and they enter the word like cookbook? Like that's a problem. So now I have to like not only try and parse it, but then I have to be like, oh, well, first I have to see if number is equal to not a number, and then I have to handle that case. And then if it is not a number, but it's less than 0, I have to handle that case, right? That's a lot of work to do, which kind of comes back to, this is the bottom one here, which is what we call like more C style, which is look before you leap. It's like check everything first. You do all your checks up front, then you pass it into the function. Whereas these high level languages, JavaScript, Python, etc., there'll be much more of this like just try and do the thing and figure it out later. And that mentality shift's really interesting, because that's what's kind of happening with the original version of this code here to some extent, is that you don't know when you call this if it's going to work, because you don't know, like parse int here could return a nan and not a number if someone passes in the word cookbook. It could parse the string into a number correctly from standard input, but again, what if someone enters -5? There's a lot that could go wrong. However, by wrapping it in this try block, what we're saying to JavaScript is anything in here is listening very carefully for an exception, right? So I call this function and I'm like listening. And if they start screaming, if they throw an exception, start yelling, what we're going to do is we're going to stop what we're doing and we're going to jump straight to the catch block, kind of like a backup emergency section of code. So we call this function knowing darn well it might fail. I could simplify this code for a second. And then if it fails, we catch it and then we print out something to the terminal. So we don't have to do any checks or anything like that. We don't have to check if it's going to be a nan. We don't have to check if it's a -1. We delegate that to the square root function. We run this code. If someone enters cookbook, I just get nan and... Did I save that? Is that right? Oh, it's not even... Yeah, it's not less than 0. That's kind of funny. I should probably be like, or x equals nan. I don't even know. No, nan's a type, isn't it? Let's not do the cookbook example. I normally don't do cookbook. I normally just stick to negative numbers. I think the example's too simple. You do -4, you're going to get this error now. Error when inputting, error input less than 0. So we've handled it. We haven't had to check everything in advance. We've been like, screw it, let's do it. And yep, something went wrong. Okay, something went wrong. That's the outcome there. Yeah. That's a great question. So this is like a variable name in the sense that it can be anything, right? Like, yeah, this could be potato. What this is, and this is really important, what you're catching is you're catching the exception that was thrown. You're catching this object here. So now you can start to unpack it. It's like the square root function, if something goes wrong, it creates an object that contains some information, in this case an error message, and it then throws it. Throwing it halts the program, starts kind of screaming up through the stack. The part that called it was like, oh my God, something I called is screaming, time to jump straight to the catch statement and then deal with it. and this is the new error that was passed in. Which is why when we print it out, you'll notice on the terminal, we got this like error when inputting error input less than 0. So if I just paste this here for a second, what's actually happening is that I'm printing this out to the terminal, which is this part, but then this part is me trying to print an object. You know when you print an array, you print an object in JavaScript and it tries to print it out to the terminal as some representation of something as a string? It's like the same thing here. So this error input less than 0, that comes from this, obviously. Where does this come from? That is just, again, it trying to print it to terminal. The same way if I say like const a equals 1, 2, 3, and I go console.log a, it's like, what am I going to do with that? I'll probably just make a random string for you so you can see it. So that's what's happening here, is we're just printing an object. Yeah. Yes, you can have multiple throws in catch. I'd say that for loosely typed languages, it's not that common. So like, let's say you're working in a C++ or Java. Often I'll see a lot more people catching different types of errors. Yeah, it's not even really to do with the typing, to be honest. It's like, it depends on how your functions are set up. Like, for instance, you might have a function that takes in a square root, and you might have a particular throw for if... I'm just trying to think, actually. I don't really ever do multiple throws in JavaScript. I've probably done most of them with C++. I imagine multiple catches, sorry. I don't think is that common? Yeah, it doesn't exist. So in a language like C++, for instance, when you catch something, you would look for certain types. You might be like, did they throw a error A or an error B or an error C? But because there's not really types in JavaScript, it's just like there's just an exception. It's just an exception. So what someone might do, though, is they might say, well, if potato dot is instance, they might do some, sorry, it's not how you write it. They might do some funny kind of like type checking here, like, is it an error type or something like that? So there might be like ways of dealing with multiple exceptions in the single catch loop, catch block, by like checking, is it this type of error or that type of error? Or even checking the string itself. You can extract the string directly, I believe. I think it's like dot message or something. Let me just check what it is. Yeah, it's dot message. So the actual string I gave to the new error function that the object I created in JavaScript, I can capture with the dot message thing. It's just when I try and print out the whole object, it prints out the message with a little error prefix. But this is just me printing out the error directly, which is why you'll see in the previous examples, it said error colon, whereas here it just says like nothing. Yeah.
So when it's converting, when it's like producing the message, does it basically do the two-string method on error and then print that?
Yeah, it literally just does the two-string method on the error. Exactly. Do you have a question? Yep. It's a good question. So when we catch the error, why don't we see all of this? So the reason is what this actually is this is an error being thrown and no one dealing with it at all. And it goes all the way up to the top. And then basically the Node.js system is like, man, someone was crying. No one listened to them. I'm just going to have to tell them what happened. So it's like kind of like a signal to you that like something went wrong and no one dealt with it. Because in theory, because these stack traces, they kill the program. So sometimes you'll be like, I'll be writing a program and I'll do something. I'll maybe give it a bad input and the Node.js server crashes and I'm like, and I get a stack trace and I'm like, okay, that was an error that wasn't handled, will be the way you think about it. That's an exception that no one caught. We should probably go and figure out how to catch that exception. So this program will kind of work here, just to check again. Seems to work fine for negative numbers and whatnot. But then you think about, well, how do I make this more workable now? Is I might ask someone to enter it again. Be like, well, if there's an error, let's actually give them an error when inputting and then prompt them a second time. So I go -5, and then it says error when inputting, error less than 0, please enter a number, and I try 5. Okay, so that works. So this is kind of the point of exceptions, is we're more gracefully dealing with this kind of problem. Then you think, well, that's not going to work, Hayden, when someone enters -5 twice. because it's just going to crash again. So that's where you start thinking, maybe I'll put this in a loop. Maybe I'll basically say, while the input's not successful, we're going to keep looping. And what I'm going to do is I'm going to try to capture the input. I'm going to console log the result. And I'm going to set success equals to true. And I really like this example because I think it demonstrates to you how we use exceptions, which is that I've written this code here like it's meant to work. I'm not checking anything, you know. I'm just like, yep, we read from the terminal, we send it to square root, we set success to true. It's like I write it like the best case scenario, but I wrap it in a try block to say, if anything goes wrong that I don't understand underneath all of this, I will get told by it and I will handle it here. So that's a great piece of code because I can go and run it and it'll say, you know, I enter -5 and -5 and -4 and -3, -2, -1. And then and then I enter, screwed it up. And then I enter 5 and now it works, you know? And this is much easier than kind of having a loop and then every loop you're reading in from the input and you're checking stuff. Now the interesting thing here is it's only stuff in the try block that listens for the exception. So let's imagine for a second I just move these two things up here. Functionally, this code's still the same because the try block is just like an if statement, like the code just moves into it and keeps executing linearly. So here I'm like, okay, I'm going to prompt it, I'm going to console log it, then I'm going to set success equals to true. But what will happen in this case here is if I enter -5, the program crashes because no one dealt with the exception. No one dealt with the exception because no one was listening for the exception because in the part of the code that an error happened, it wasn't in the try block. If I move this particular line of code down into the try block, it will work because the square root is the function causing the issue. Now, if I wrote the code like this, everything would work fine unless there was an exception in the prompt function. You know? So it's like anything outside of the try block, if an exception is thrown, it's not getting caught. Now you might be like, why would we not just put everything in the try block then? You know? Like if exceptions can happen, let's just put all our code in a giant try block. There's probably a couple reasons you wouldn't do it. I think what I'd say is like often with code, there can be like multiple things that go wrong, and sometimes having like separate little try catch blocks is really useful to kind of say, hey, we're going to go do a thing over here, and if there's an error, we'll handle it. And we're going to go do an unrelated thing over here, and if there's an error, we'll handle it. So a good example might be this code here actually, is that what happens if you actually, for instance, were like, we're going to go and read in the input, and we're going to try and read in the input, and if there's an error reading in the input, then we will deal with it, right? A whole set of errors might happen over here. But then after that, we need to go and square root it, so we'll try and do that, and then if something goes wrong there, there's a whole set of errors and handling over there. So typically, like, you'll put the code in a try block, not just because you think it will throw an exception, but typically if you think like the way to handle any error in the try block is the same. So the second you would put lots of lines of code in the try block, if the way you wanted to deal with errors based on different things that could go wrong would be different, you would probably break it up a little bit. It is a funny little piece of code because if I go and run this now, you'll see that it gets really confused because it's like, hey, I can't find input because I tried to parse input here, and it's like, I didn't know where that was. Because remember, every time you open a brace in a language like JavaScript, you're creating a new scope. So what that means is like input's defined in this try block, and when the try block ends, it's out of scope now. So, well, how do you get around that? Well, you could do it a few ways. You could say like let input equals blank or something, and you could then like now input is in scope the whole time. That would work, but it might not be ideal because you're like, now I have to deal with a case where, you know, I don't know how to throw an exception with this. I'm not too sure. The other thing you can do is you can nest try catch things, I'm pretty sure. I don't do this a lot, but pretty sure that's fine. Yep, that's fine. Like you can just nest them like any control structure as well. I'd say generally speaking, like 99% of the time, you've just got a try catch block by itself. You know, now you might be thinking, and this is all for iteration 3, remember? Not to do with iteration 2. Not to do with iteration 2. I'll say that another 5 times because there will be questions that Yuchao will have to answer in a few days where someone says, do I need to do this for iteration 2? Where might you find this useful? probably in your project in iteration 3, not 2, where you have functions now that you don't have to deal with all these return error objects. You can actually just say, I'm going to throw an error and then catch it. Catch it in your server. Because then in your server, like let's say you've got your app.post, admin auth register, something like this, your request, your response, instead of just being like, yep, const token equals admin auth register A, B, C, D, and then being like, because what do you normally do? You normally like, hey, if token.error, we talked about this the other day, response.400, response.json error. You can find more elegant ways of dealing with things than that. By simply saying, I'm going to try and call admin auth register, and I know that the function I wrote might throw an exception if something goes wrong. So if it throws an exception, I'll deal with it this way as well. Now, you're not going to get huge returns on your code. Your code is quite simple for the project, so this might just feel like a slightly pointless refactoring, but depends on the function. But you can do some fun code cleanup things with it, but I don't want to burden you with that now because this isn't really something you're going to worry about for a few weeks. People have asked in the chat, Big Back Ben has said, is this meant for debugging or are catches used in function processes? Tries and catches are used everywhere. I'd say like in most languages, again, like Java, JavaScript, C++, Python, pretty much all errors would be dealt with via exceptions. They're just a great way because, again, the alternative to exceptions is typically the crashing or convoluting the return type and having to define meaning of that. And that's really bad because I gave the C example earlier, right? I don't know where it is. I probably deleted it. But it's like the C example, for every different function you call, you have to go and learn what an error means. So think of exceptions as like a standardized language where everyone understands that I'm going to call something. If there's a problem, it will notify me by this well-understood standardized method of throwing an exception. Now, one thing I did gloss over a little bit that I think is really important to understand, I kind of said it, but maybe didn't show you, is like, take a look at this. See this code here, back in exception 2? When I run this and I enter a number like 4 and it square roots it, you'll see it prints out hello on the terminal, right? That makes sense because I enter the try block, I go line 12, 13, 14, everything's fine. And if there's no exceptions thrown, what do? We skip the catch block, right? So we never enter the catch block unless there's an error. That probably makes some sense. But here's the interesting one. What happens if I do -4? Suddenly now I have basically exited the program without ever console logging hello. You'll see no hello there. And this is one thing we need to be very mindful of with exceptions is they do literally halt the program flow. So once the exception is thrown from square root, like think about it like this. The program starts, it comes through 11, 12, 13. It gets to 13, we go inside square root. We go up to line 4, 4, 5, 6. Throw new error. From this point on, lines 7 and 8 is never executed for the square root function. We immediately stop on line 6. We kind of end the function, and we say to the person who called us, an exception has been thrown. So we come back up to this here, line 13. And then on line 13, it's like, oh my God, we have an exception. Am I in a try block? I am in a try block. Great. I'm going to stop executing code on line 13, and I'm going to go straight to the catch. And then I'm going to continue on from there. So that's why we describe it as like exceptions disrupt the normal flow of code, because they literally do. They halt things where they are and just bubble up until someone deals with it. A very, very interesting thing. Now, the good news about that is that halting the execution flow makes it really easy to code, because again, you can just kind of be like throw exception. You don't have to get into that whole like, oh, well, you got to carry the return type down, and then how's someone going to deal with it? And then, because your projects are really simple, you might not have thought about this, but what if you call a function that calls another function that calls another function that calls another function that might have an error? What if you're returning an error object? Now you've got to handle that error object and figure out how to pass that back up to the third function and pass that back up to the second function and pass it back up to the first, Like when there's layers in your code, it gets really hard. Whereas with exceptions, you can call from function A, function B, C, D, and if there's an exception in D, you know that the way the ecosystem's set up is it will just halt it and bubble that back up until you deal with it. Sometimes you'll call functions that themselves throw exceptions that you never see, because if you call function B that calls C that calls D, and D throws an exception, function C or B might deal with it, you know, because like software is just layers at the end of the day. I had another question here, which is, I think used in function processors, at least in Java, you can read write to files in a try catch block because of file not found exception. Maybe I didn't understand Big Back Ben's question when he's like, debugging or are catches used in function processors? I mean, I guess everything. I think I said, I don't remember what I said actually. They're just used to handle errors. I don't think anyone would, like you'd never write an exception just to debug. You'd write an exception because you're like, it looks like something can go wrong here and I'm not dealing with it. I think another thing is because you all haven't really seen these exceptions before, I think one false economy I might be confusing you on is that it's not very common for you to throw your own exceptions. It's much more common that you'll be catching exceptions. Like, typically throwing exceptions are like what you do when you're writing libraries. Now in the project you might throw a bunch of exceptions because you know you're writing all your admin auth registers, but day-to-day programming, like, I don't know, like if I don't even think I have that much in terms of like, if I look at the Git run website, like if I look for any throw in here, there's like 5 throws that I have, and if I look for catch, there might be less. There's like a lot of catches, you know? Catch, 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 ignore that stuff, catch, 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 catch. So the majority of time, you're likely to actually be, like the reason this topic is relevant is not because we're like, you're gonna go away and create a bunch of errors. It's because we're like, the world is full of these errors in JavaScript land. Your job is to handle them. It's predominantly what you'll end up doing. The other question was, can you repeat why this is better than doing the return error? I think I covered that a little bit since the question in a couple of different ways. It's less code. It's quicker. It's more versatile for multi-layered functions. You can attach more meaningful standardized information with it rather than having to be contained by the return type. You don't have to deal with like union return types as much, again, where there's like one object or a second object. In general, I would say they're nearly universally better. There's one circumstance where I'd say they're not better. You know, I mean, there's going to be more than that, no doubt. But the main one that I've probably seen is that it makes code really hard to reason with. What this means is, so a general rule of reasoning with code is that if you want to make sense of code, you want to avoid code with jumps in it, right? Have you all done 1521? Or half of you done it? Who hasn't done 1521? Hands up. Okay. So like, you know, I haven't done, 1521 is a relatively new course in the grand scheme of things. Do they teach you like go-to in there? Or you like jump? Yeah, and like jump commands and stuff. Like anytime your code does something that emulates a jump command or a go-to command, it's really like it's all kind of out the window, right? Because like if you think about normal programming, while loops, for loops, if statements, else statements, functions, I mean, even functions jump around a bit, but it's like, it's really easy to follow the code flow through, you know? Like you can just be like, I'm entering my function, there's a while loop, I'm looping for a while, and then I come down, and then I make a decision to go into the else statement, and I always kind of describe it as you could often, a lot of code you could kind of draw with a pen pretty easily, and when code jumps around, it's really hard to quickly figure out what happens. What I mean by that is, you know, if your code just returns an error object, well, you're like, oh, there's the return statement, I'll go back to who called me, and you move through it like that. Exceptions kind of break that a bit, because if you have, say, function A here that might try and call function B, and it's, you know, ready for an error, catching an error, but then down here you have function B, and all function B does is call C, and all function C does is call D, and all function D does is call E, but then there's also like all this other code down here, and then maybe some other code here, and then all E does is throw new error. It's like, it's a very difficult thing to kind of quickly reason with how this is going to work, you know, because you kind of are like, okay, well, I throw the error, I've got to go to E, D, and then E, and then C, but then this isn't executed anymore. You know what I mean? Like, so that kind of, that jumping element is its biggest strength, and is why majority of the time, and why it's lovely, and why a lot of languages use it. But there's also that downside, which is that it's harder to reason with, which is probably why some really simple languages like C might not have it as well, because it's just very methodical. That'd be my guess. Testing with exceptions. I'm not really going to spend much time on this because you can kind of go look at the slides and figure it out yourself. But this is more probably relevant for like week 8 once you get into iteration 3. What's it called? Square root and catch.test. So with iteration 3, you might have a function that throws something. Okay, you get that. It's not even iteration 3 because you're not even going to be testing exceptions. This is probably more to do with labs, sorry. Not to confuse you. Because with HTTP servers, your tests will never see exceptions, right? Because everything's communicating via the network, via HTTP requests. So your server might throw exceptions and you might catch them, but it's not like your test would ever do something that returns an exception. It's just making an HTTP request. So this is probably more for like labs and stuff in week 8, which is if you have a function that throws an error, or you have a function that you write to throw an error, then you basically have to rewrite it like this. So in these cases here, I'm like, yep, square root of 4 should equal 2. This makes sense. This is just testing from like week 2 or 3. Whereas here, I'm like, how do I test it if I call the square root of -2, I want it to throw an exception. It's a funny little piece of syntax. You really won't have to do much of it in the course. If I just wrote it like this, you probably wouldn't be that surprised by it. You'd be like, okay, that makes sense, right? Square root of -2 should throw something. This whole element here is a little bit weird. What you're doing here is basically passing the square root in. Like the equivalent here is saying, I've got a function called run square root -2, and that function simply calls square root -2. That's what this is. It's a little bit weird. It's just shorthanded because if you think about it, you're like, well, if it's an anonymous function, I don't need the name, so I put it in there, but then I use the function syntax thing, and I'm like, well, I'll just condense that down to this, and then it's like, because it's a single line thing, I'll just condense it down to this, and then you suddenly end up with this code that 60 seconds ago looked really weird. This is mostly because how expect will work with this. It's just to do with exceptions. If you're going to have something that throws an exception, it wants you to give it the function that it's going to call later as opposed to the result of the function, which makes sense because think about it. What's happening here is you aren't passing in square root to this function, right? You are calling square root, you are getting the result, which is 2, and then you're passing 2 into expect like this. So that makes sense, but when it comes to an exception, you can't pass the square root of -2 into that function because the square root of -2 tries to be evaluated first, right? And it wants to turn itself into a number like 2, but because it throws an exception, it's never going to return anything, right? Because exceptions don't return stuff. So we basically need to kind of wrap it in a function and say to Jest, hey, here's a function I'm giving you, so you can run it later, and you can kind of run it quietly behind the scenes in a try-catch block yourself and check stuff. So it makes sense why it does it. It's just not necessarily intuitive to read. You had a question?
I was just going to ask about that if that was being
Exactly, yeah. If you didn't pass it as a function, if you just tried to pass it as square root of -2, it would literally throw an error before expect is called. So like in the middle of the Jest test, you would call square root of -2. Square root of -2 would panic, and it would just like halt executing at this line and kill your tests anyway. So it's a funny little thing. But again, you won't really have to deal with this in this course. Like exception testing is pretty common in Jest, but for iteration 2 and the rest of the course, all the tests you're doing are again at the HTTP layer, So like the kind of tests you'll be doing are like more checking the status codes and stuff. That's kind of your equivalent of error checking, is checking HTTP status codes in the project. But I do think, unless the course has changed in a while, last time I looked a year ago, there is still a lab in like week 8 or something, or week 7? I don't remember. I don't know what the labs are like at the moment. That does ask you to do something with exceptions. Are there any questions about this before we kind of wind down, take a quick break, and move on? Yep.
So we could like throw and catch it.
Yeah, absolutely. Yeah, 100%. Just like you can import from one function, one file to another. It's the same with exceptions. It would nearly be very strange to be throwing and catching exceptions in the same file because the main benefit of it is that you can kind of, catch things you don't fully understand. Because quite often we use them with libraries like, trying to think what like one of the most obvious examples that, because like let me see if JSON.stringify, if this throws an exception or not. Yeah, so like JSON.stringify literally throws an exception. So let's say you have a program where you're like, let me just do this to quickly wrap it up. If you have any other questions, put your hand up or ask in the chat, because I'll just stop after this if there's no more. Let's say I'm just going to modify exception 2 here. I've got my prompt function. I'm going to read in from my input, and then I'm like, give me some JSON to turn into an object. And let's say it's really simple. I want them to give me a JSON string. So what I can do is I can say object is JSON.parse the input, and then I'm just going to console log the object, right? So I'm just asking them to give me JSON. I'll try and convert it to JavaScripty for them, and then I'll just print out the JavaScripty. And this will kind of work fine if I run it. If I'm like, yep, the object's just that, or the object's something like, name is Hayden. That's all valid JavaScript, right? However, JSON, sorry. However, if I type in something like, hey, I get an exception. JSON.parse threw an exception. You've probably used this throughout the term at some point in a lab or something. So I'd be like, well, I know that might throw an exception because the user might give me crap. So you know what? I'm just going to go take all this. I'm going to go wrap it in a try block, and then I'm going to be like, yep, I'm going to catch the error. And then you know what? They can just kind of deal with it. I'll just be like, not valid JSON, please run the program again. So back to my point about this is like the essence of exceptions, is that we're not doing much defensive programming here. We are saying that I'm going to call this function. I know that if something goes wrong, it will complain back to me, and I'm just going to handle the complaint, which is that idea again of seek forgiveness, not permission. So I run that again. I pass in BS. It's like not valid JSON, run the program again, and things kind of work. So that's like a really simple use case of like most functions you probably interacted with do throw exceptions, like JSON.parse or certain libraries as well. Just often we don't deal with them. And like there's lots of exceptions, like take the git run website again. There's tons of things that can go wrong with that, but like some of them are so obscure and unlikely, like I don't bother to go and catch any possible exception because I'm like, why would that happen, or I don't care, frankly, like in terms of if if someone, instead of entering a ZID, enters the word potato into the login website and it causes the call to a particular route to like fail. I'm like, well, you entered potato. I'm not going to waste my time trying to deal with it. But again, it totally depends on the software you're writing, because Git run's just a tiny little website that not many people use right now. But if it was a really, really important piece of code, you'd have to be going through absolutely everything. Like what's every possible error and exception that could be thrown so that we can deal with it as well. Cool. Hope that was interesting. That's pretty much what I said before. It's mostly the testing stuff is mostly to do with the labs and not the project. Cool. Hope that is fun. All right, let's take a short 4-minute break, and then we'll keep going with the second part of it. It's all right. Start again. So, for those that missed the earlier part, software design is important. When we talk about building software, I think when we're younger, we can just get caught up on raw coding ability. And that's kind of what I want to try and move you away from a bit today, which is really how do we make the code elegant? How do we make it like better for the future? And I'm going to define a bunch of these things. So what we're talking about in this one, we call it a design lecture, but the way that renamed it is maintainable software. So we want our software to be maintainable, a massive point. And maintainable software, if you take nothing else away from this, it's software that is resistant to breaking when inevitable changes happen. All software is living, right? If you have software that doesn't change, it's probably because it's a worthless piece of crap, right? Like if you have something that people use or people like or has any value to anyone, it's going to be constantly changing because either you're going to need to fix something or add something or people want something, So software is like a live changing thing all the time. Our job is to write software that when it inevitably gets poked and pushed is as maintainable as possible. Now this isn't actually specific to design either, because this is also true for, say, testing. Like one of the reasons we write tests, one of the reasons we have jest tests is so that inevitably as your code changes, you have a fallback, a protection that helps you make sure it's working. So in this one, though, we're going to be talking about code design a bit more specifically. Why do we care about maintaining software? How do we maintain it? And mostly examples of maintainability. We have a little bit of short time, but I think we should still be able to get through it. So recap, what is software engineering? Software engineering is where we focus on building the right software for the right people. That makes sense. And making sure that it's maintainable over time as it grows and changes due to lots of different reasons. That's not in a degree sense, but in a semantic sense. Computer science is about the understanding of computers and how they work, algorithms, data structures, exceptions. Exceptions is a great topic about computer science to some extent, how we unpack it. Whereas software engineering is really about, sure, software's cool, but reality is software is built by people and handed to people to use. And there's problems that come with that. Making sure it's maintainable over time as it grows and the people who work on it change is the key point. That's what we're going to be discussing today. Why do we care about maintainability? I'm trying not to repeat myself too much here. But basically, the less maintainable software is, the harder it is to change. It's really simple. You might have heard this referred to as spaghetti code before. As software gets bigger, every time you touch something, it is more difficult to change. And you all probably get this because you've all probably experienced something like this at some point where, maybe you had a really big Word doc in high school that you were writing notes in, or maybe you had some kind of project in the backyard or some kind of, Lego thing or whatever else you might do. And you're like, the bigger it gets, there's just an overhead that comes from it existing, And you want to make sure that when you go to change something, it doesn't screw up a bunch of other things. This is more important now than ever because of how iterative software is. I don't know if I gave these examples to you guys this term, but video games, for instance, never used to be as iterable. Like you kind of like make a video game like Mario Kart, and it would be released, and it was just released, and that was kind of like it. If there were bugs in it, there were bugs in it. No one's going to touch the code. No one's going to change the code. No one's going to be tweaking it or maintaining it. Very different nowadays because of how iterative everything is. You use products all the time like Spotify, where someone is probably making changes to Spotify every single day. So if we make it difficult to make changes, then we kind of screw ourselves up. Why does software change over time? Pretty simple. Different people work on it. That makes sense, right? Like a lot of big corporates will have something like a 5 to 10% churn rate every year, maybe something like that. That means it doesn't take very long, maybe like in a decade, or maybe in 10 years, most companies have had more than half of their staff replaced in software, would be my rough guess. That's not quoted from anything. That's just anecdotal aggregation. So that's massive. So you got literally like most of the products you use probably have people working on code that they didn't write or have to understand code they didn't write. Most code we're going to work on in our lives is not going to be things that we just like wrote from scratch. It's one of the worst things about uni in a way is that uni gives you this real like clean slate feeling all the time. And like you'll just very rarely experience that longer term. Requirements change over time. That makes sense. You know, Netflix put ads in at one point, right? Remember that? I don't have Netflix, but I got told about it. They're like ad tier, the cheap tier on Netflix, where like you get Netflix a little cheaper and you get to watch ads like it's YouTube. It's like, all right, well, think about that. Someone high up was like, you need to add ads to Netflix now. And then someone who built the Netflix player or a team of it were like, they might have been like, oh, that's really easy. We structured it in a way that it's really easy to change the code to like put ads in. Or they might have been like, oh my God, that is going to be impossible with how we've done it. We're going to have to rewrite the whole thing. Like there are two different scenarios that could have happened there. We also need to speed up software over time, and we need to fix bugs. Bugs are inevitable in software. Generally speaking, if you have software that isn't very likely to kill someone, there's likely to be a lot of bugs in it. There's some software out there that's tested very, very thoroughly. The examples we usually give are things like, you know, plain control systems, or things like anti-lock or like brake systems in cars. Because remember, like when you do things in a car, like steer or brake, like there's electronic signals being sent. They make sure those things work like very, very well. Not ever perfect, but very, very well. Or as you go use a product like Canva, you'll come across bugs all the time, because like no one's going to die if Canva gets it wrong. So you might as well go really quick, you know? Build stuff really, really fast, get 3 times as much stuff done if that increases bugs by 10%. You know, that's a worthwhile trade-off for a business. But that means you've got to fix a lot of bugs. Code generally always grows and never shrinks. You'll never get on top of it. I think this is an important concept, because you see this all the time as people being like, oh, we'll clean it up one day, right? You might hear that. One of my favorite conversations, it was with a guy who was from Atlassian. He's like 50 or something. And I think he'd been there for like 15 years, since like 2008. That's a long time to be at a company as big as Atlassian. You know, that's like 7 years before the IPO. There was probably like a couple hundred people there or something of that size, and it's gone up by like 20 times. And I was talking to him about companies and growing, and he was just like, he's like, the one thing I've learned is just like, you never get on top of it, you know? It's always chaos. It's always chaos, because the second you get on top of it, like, you know, if you get a bigger team or you get more people, you're just going to like do more, you know? Like the ambitions just go up. So you think, oh, we'll just wait till we hire more engineers, then we'll clean up the code. Sure, what happens? Why are you hiring more engineers? Probably because someone got money. Why do they get money? To grow the organization, right? To make it more successful. This isn't true absolutely everywhere, but it's true probably nearly everywhere. It's just that software always grows, never shrinks, and you don't have time often to do any major cleanups unless you like do it on the spot. That's a broad brush. There are exceptions. I'll give you a good example. At my company, we had some, I think we added a bunch of linting rules into our linter for some like really bad code practices, right? We ran the linter with the new linting rules, and it was like 22,000 lines of code are bad. And we were like, God damn it, like we don't have any time to go and fix all those up. That'll be like the whole team for like 2 weeks cleaning code. And it's like, no one's gonna really justify cleaning code. Like that doesn't really create an outcome a lot of the time. So I was like, well, how do we manage that? Well, what we did was we basically actually said, we're gonna configure the linter to allow exactly 22,340 errors and no more. And therefore, when everyone went and added more code that was problematic, they got like prevented from adding more code that was worse. But the old code was still kind of fine. And then every few weeks, we get someone to like go in and clean up like a few hundred lines of code and bring that linter error down, you know, from like 22,300 to like 22,100 or something like that. So I don't want to paint like a super bleak picture, but I'm like, that's literally what managing it looks like quite aggressively. There's no scenario everyone's like, let's just stop, you know, working on Netflix for 2 weeks and clean up all the code we've written. If you write bad code as you go, you're going to end up kind of being haunted by it. And it's very difficult to delete code as well. Again, a lot of these things you think, well, I can delete code. Code gets not used all the time. Yeah, but the problem is like, you know, it's very like, you know, experience. You like move into, you ever had this thing, I can't think of a good example. You might like, maybe you go visit a family member or something. You go to their kitchen. You're like, this place is a mess. And then you like pick up, you see something on the bench that looks like, you're like, why is that there? It's just clutter. And you like pick it up and you realize there's like a broken tile underneath it. And they've like put that thing there to hide the tile. And you're like, oh, okay. Sure, and this is like what happens with software is it's very hard to just delete stuff that you don't know very deeply, because you're like, I don't actually know the full extent of how this is going to go. And everyone will try at one point, but all that happens is you delete some code you didn't write and don't understand that you're pretty sure isn't used. And then something disastrous happens, and then someone's like, Hayden, you're an idiot, and then you're like, better not do that again, you know, without really thinking about it. So it's very hard to also delete code. Maintainability as a general rule is more important than performance. These are broad brushes again. There's going to be some of you here that actually go and do certain jobs where you need the fastest language and you don't care about how maintainable the code is. You just need it to be like hyper fast, and that's like it. But that's such an infinitesimally small number of you. Most of you are going to get judged in your professional lives as to how maintainable your code is, even if it isn't fast. And I think what's really important is that if code isn't maintainable, performance issues tend to come when you have to change it anyway. Because if you have code that like is maybe not the fastest, but it's pretty easy to change, then when someone else comes in later and changes it, it usually doesn't have a big impact. Whereas like if your code's so hard to understand that someone like doesn't know how to work with it, they might introduce something really, really slow. A good example is, you know, let's imagine that you have a particular piece of code you wrote that like queries a database, you know, it takes like 1 second to query the database. And then someone else comes along and is like, I'd really like to like get just a little bit of extra data from the database. If your code's really maintainable, they might be able to tweak your code and just get that same data back in 1 second. Whereas like, let's imagine someone else wrote really awful code that instead of taking 1 second, it takes like 0.7. And they're like, I'm so smart, you know? 0.7 seconds is like really quick. Someone comes along to try and modify that, but it's written in such a convoluted, difficult way to understand that the only way they know how to do it is to write their own query. You know, so now they're fetching from the database maybe in 0.7 seconds too, and now it's like 1.4 seconds, you know? So it's very easy to get caught up on performance. I mean, even when performance is important, maintainability still matters. And the good thing is code that's easy to maintain is generally easy to optimize as well. Because code that is just hard to work with, you just don't know what to do with it because it just kind of breaks all the time. Okay, how do we make our software maintainable? A few different things. There's testing, which we've talked about. There's system design, which we don't really cover much in this course. Again, back to the point about you haven't really designed systems to this point in your life much. So it's like kind of telling you about it's just going to kind of gloss over a little bit. But I continue to make sure that I'm lobbying everyone so that it's important in later courses, because that's when you'd really love to hear it. And then code design, because system design's more like, okay, how do we generally structure our server? Do we like have an auth file and a quiz file? And in this course, we kind of largely help out with a lot of the system design stuff because it's kind of dictated to you. If we just gave you a blank slate and we were like, you put whatever you want, wherever you want, put whatever in server, auth, other files, or whatever, that would be kind of the more broad system design. But code design is really looking at a single piece of code, maybe like just one file, and being like, have we written this code well or not well? And that's what we're talking about today. So code design is typically something that we do between when we write tests and when we write code. It's when you understand what your code needs to do, but you don't exactly know how to write it, you know? And what happens when we're quite early on in our like professional lives is that we typically just don't spend a lot of time thinking about how to write it. And the reason for that is not because we are silly or stupid. The reason for that is because whenever you do anything, you're always drawing on experience. You know, like if I say to you, yeah, let's go get some food, you know, you might think about all the times you've eaten bad food, or that time it was expensive, or the time the queue was long, you know. You'll draw upon that to kind of be like, what's going to be the right general approach here? And be like, you know, that time you're like, yeah, let's go to Randwick and get lunch, and then you were late for your lab or something. Like all those things kind of stack up. That's what happens as a software engineer, is you have that stacked up. So this gap between like, I know what I need to do, but I'm not sure how to do it yet, your insights on that just get better with time, and there's no real good way to do it except for you to write meaningful code. Some people might say it's good to write a bunch of pet projects or like personal projects. Personal projects are great. They're really good, but the thing that will be even better is anything you have to write that involves multiple people and might be looked after for years, or has been already looked after for years, you know? So making a cute little app is a great idea. It's way better than nothing, but if you can ever get involved with like a CSE SOC making some, you know, newsletter system or whatever else, that stuff's really often going to be just a little bit better on terms of the code design front, because you'll just have to work with other people. And a lot of it comes, again, if you're not working with other people and people aren't using it, you generally don't get punished for bad code design. And it's only punishment that we generally learn things. So what I want to kind of frame, how I like to frame these things is in in 6 questions, even though there's 7, but let's disregard that. I don't like design principles that much when someone says, like, here's a certain pattern or here's a certain rule to follow. I think they're really tricky because it encourages people to think, like, you know, really rigidly. And I think the best way you can approach design is asking yourself questions, you know, like interviewing yourself as you think about stuff. And these are the questions. So it's like when you write a piece of code, asking yourself, is there one source of truth for this? That's a great question to ask. So when you repeat yourself in your code, a change in that value or capability might require changes in multiple places. So if you're asking yourself all the time, is there one source of truth for this? Is there one source of truth for this? That's great, because if you make it one source of truth, you'll never accidentally change half of the equation or not, you know? This happens in larger software projects. Like, I don't know, I could probably look it up later. Maybe I could look it up now even. I don't know, let me try it out. So like, if I look at the repo for our work stuff, and I look up the cost of our product, which I don't see here anywhere. Let me see if it's around. You would hope that, like, have a look at this. There's already straight places. That's like clearly a cost there. That's a variable that's been defined as the cost of the product. But I'm seeing it here now. There's 2 other places in the code. There's another place in the code. These are unrelated 650s. That's probably, I don't know what that is, but that's probably another place in the code. That's more places in the code, and there's more pages here. So for something as critical as, say, the price of the product, what it means is that if we were to go change the price, there's not one source of truth for it. So that's not a very well-designed piece of code. Now, why is that not well-designed? The reality is probably because our prices change every, like, 2 years, and even if we had one source of truth, it's going to have to be so heavily reviewed, people are going to search the code base for it anyway, you know? So these things always have a little bit of tug and pull. Still not the best outcome, but that's the question you ask. It's like, if we have a price, is there one source of truth for it? Is this already been defined somewhere else? It's very easy to forget to change it in all locations. And then, here's where it gets funny. You might think, oh, I searched 650. Sure. What if there's a piece in the code, because 650 refers to 650 cents. What if there's a piece of code where the price is defined as 6.5 in dollars? You know? I didn't search that. That might be there. You can run into problems, you know, even though you think you might get on top of it. They sometimes refer to this as like the don't repeat yourself method, which makes sense. It's all kind of the same. Every piece of knowledge must have a single, unambiguous, authoritative representation within a system. That's a really big adult definition for you there. And here's a piece of code. We've got one here. We usually try and work with this one. We call it dry dirty because it's like don't repeat yourself, the dirty version of it. It's a piece of code. We import argv from process. We, if the number of elements that are passed in is not 3, we kill the program. We then try and parse in the third element, index 2, as an int. And then if the number that's passed in is 2, we print out all the powers of 2 between 10 and 20. And if it's 3, we print out all the powers there between 10 and 20. So you can kind of see that. You don't need npm installs for this piece of code because there's no libraries that are npm based here, but I'm just doing it in case. Cool. So now I go, I can just, npm run dry ts node dry dirty. The point is with this one, I need to run it with like an extra thing, like a 2. And it'll print out all the 2s. And if I do a 3, it'll print out all of those. So it only works for 2 and 3. So forget that it's a bit of a silly program. The idea is like, how do we avoid repeating not repeating? Yeah, when we ask the question, is there one source of truth for this? You go, well, what are there things here that there are multiple sources of truth for? Just like quick point them out. Yeah. Console log, yes, that's true. I'm going to come back to that one. Besides console log, what is there? Sorry? The what condition? The for loop condition? Yeah, the for loop condition looks the same. That's definitely something that should kind of tickle your brain. You're like, it looks like we're doing the same thing there. Sure. Yep. Squaring? Yep. I don't know why that's actually written different, but I think this used to be a Python example that I modified. Yeah, and the other one, just to speed it up, is like process.exit. We have the same way to exit the program in 2 spots. So if someone later on goes, oh, let's figure out how to, maybe we'll replace it with exceptions, you know? It's like, well, now they have to go and do that in 2 different locations. So that's kind of where things get a little bit funny. You might try and say, clean up this code and be like, well, let's focus on the process.exit part first and say, hey, well, if num is not equal to 2 and num is not equal to 3, then maybe we'll process.exit as well. Now, this is actually a really difficult one to kind of clean up and avoid repeating ourselves, because we kind of need to check argv before we parse the int. You know, we need to know that the element's there before we look for it, but it's only once we look for it that we can check if it's the right value. How do you get around that? Maybe you could do something like, you know, create a variable called, you know, early exit equals false, and then here I'd be like early exit equals true, and then if this is bad here, and then I could say, you know what, if early exit process.exit1 or something like that. That could work potentially. A little bit verbose, you know, not the nicest thing in the world. You get into these kinds of recursive loops with this stuff though, because now you're like, aren't we just repeating early exit? Aren't we just doing this and that? It's a little bit interesting. But if we look at something like this, these nums as 2 and 3, I can see that these 2 loops are pretty much identical, literally, except for this number 2 in these 2 cases. So then you think, okay, well, what can I do here? Can I turn it into a function? I'll maybe say like print powers 2, and then I'll go and create a function here called print powers, where I'll literally just pass in a num. I'll take this code here, move it up there, replace the 2 with num, replace this with num, and then I can go print powers 2, print powers 3. You know, something like that. So that's a nice way that I've kind of avoided repeating myself, the nice way that I've created a single source of truth. This code example is really great because it's a really ugly piece of code, and it actually doesn't work itself nicely into a package up, right? Like, it's not like a piece of code where we just like gets cleaner and cleaner and cleaner. It kind of feels a little bit janky. I could also change this. I might move this function to the top, but like I could also change this up by saying, well, you know what? Let's say that there's numbers 2 and 3. I'll actually say like valid numbers is a list of say 2 and 3. And then here, what I can say is like, well, you know what? If num, which is, yep, the thing I parsed, if num is not in the valid numbers, then I want you to crash. And then here too, I could also just say, well, because you think about this loop now, if I've already validated from this point that it's a 2 or a 3, I can have one single source of truth of how I call this, which is I can just call print powers, you know? Because if I know it's going to be 2 or 3, what's the point of having an if statement that's like, if it's 2, call it for 2, and if it's 3, call it for 3. It's like totally redundant. So then the code might get simplified down to this, for instance. Now you look at that and you're like, is that really easier to read? You know? It's kind of a little bit more confusing. It's also easier. And this is why I like questions, because questions promote people to think about stuff and to talk about stuff. If I was like, oh, you have the rule where you like never repeat yourself, you just kind of take that militantly. But we might have actually done some things backwards here, because they're principles, right? They're not rules you have to live every minute of your life by. I'll give you a good example. You know, this might be really weird to read, and maybe we actually do say, you know what? If we just include the process.exit back here, it might actually just look better if we just say something like this, because then we can get rid of all those early exits and these things here. And then suddenly you're like, wow, that code actually does look a lot better, you know? Like suddenly that's a little bit easier to read. But we've introduced the repetition again. We don't have a single source of truth for how we exit the program. Or maybe we do, because we can simply create a function up the top called exit, where all we do is say process.exit1, like that, and then instead of saying, you know, process.exit here, we just say exit, you know? Because well, now at least we've, you know, taken a process which, you know, we were trying to do the same process in 2 spots, and we've abstracted it away. Do you have a question?
Yeah, it's going to be print power num.
Oh, probably. I've made a lot of code changes. Yeah, thank you. Good spot. Yeah, so, you know, we might have a piece of code like that. Sure. I think what's really interesting about these examples, and I loved your console.log one at the start, because I talk about this in my 6080 course a bit. If I go back to the original code sample here, the reason, again, these questions are powerful as opposed to rules is because occasionally if you take rules too literally, you can actually get into a point, and I've seen students do this, where they'll say, you know what, I want to create a function called print, and that function called print is going to take in a string, and what it's going to do is console log the string, and then you think, I'm going to replace this with that so that I have one source of truth for how I print, you know? And there's two interesting traps you can fall into with this. The first one is like, there's certain things where when you abstract them, you are forever simply just replacing it with more things that you repeat with. So the idea of like, don't repeat yourself is a funny one, because often replacing things we're repeating, we're just replacing numbers we're repeating with variables we're repeating. So you need to kind of more think about like, not am I repeating myself, but more like, is this like something quite boutique where I might go and change this or want to change it everywhere, you know? And in the case of console log, you're not going to change it everywhere. It's a console log, right? But the other thing which is really tricky is in the attempt to, you know, when you ask that question, is there one source of truth for this? Why are we asking that question? Because we're trying to write software that's maintainable. What's maintainable software? Software that's easy to understand and change. When I do this, suddenly you as a JavaScript developer now read this code, and if I just showed you this, you'd be like, what the hell's print? You know? I don't know what that does. I got to go look that up. Now you got to go look up what that function does. And then you look up what that function does, and suddenly it's just harder for you to figure out what exactly is going on. So there's really interesting limitations of trying to answer that question. That's why it's a fun example. We've got 20 minutes left, so I'm just going to keep powering through them. The next interesting question, is this as simple as possible? Could I cut it down? Seems like an obvious question, right? Maintainable software is simple software. There's pretty much no virtue in complexity. Complexity should pretty much be seen as a bit of a shameful trait of your code. Like if you write code that is complicated and not simple, there's nothing cool about that. It's hard to feel that way sometimes, because sometimes we feel like we have to write complex code to solve the problem, and we're proud of that complexity because we feel like that complexity was the barrier in solving the problem, you know? I was writing some code for the Git run website like at 11 p.m. last night. It took like half an hour. It was like one line of code. And it was simply that we've done your iteration 1 auto marking, but we don't want to release it to you yet. So I was trying to figure out how to have it in the website where if you're a student, it's hidden from you, right? And it was like, I wrote this like really complicated query. I was like using ChatGPT, and it was like spitting out all this kind of garbage, and I thought it was meant to be like a 10-character solution, but it ended up being like 120 characters. The line was like off my screen, you know, and you kind of like, I solved it. But then it's like, you always have to stop and go, no virtue in complexity. So I got to ask myself this question now, is this really as simple as possible? It was midnight, so I went to bed. I don't know, I'll think about that later. But the point is, if it wasn't midnight, I'd be like, maybe I should try this again, you know? Or maybe I should go and look at some other examples, or maybe I'll go and figure something else out, because there's a good chance if something's complex, it doesn't need to be. Sometimes it just has to be as well. The more code we write, the more we have to maintain, the more people understand it. Like the best code is no code, you know? Like there's no feeling better when you're a seasoned developer as finding a library on NPM that does everything you need to do. And it's not because you're lazy, it's because you know that you're not going to be introducing complexity by writing code. Sometimes we refer to this as like, keep it simple. Yeah, so a couple of quick examples. If we had example 1, write a function to generate a random string with up to 50 characters that consists of lowercase and uppercase characters. How would you write that as simply as possible? We're going to need some ideas, otherwise we're going to run over time. How would you approach it? Yep. Yay, there we go. Found a library. Yeah, exactly. So it's a very mixed answer I normally get. Every second term it's different. It's either find a library, which is kind of probably the right approach. The other time is that people start being like, well, maybe I should go and like get all the uppercase and lowercase characters on my keyboard and like write them out like that. And then I'll essentially be like, well, if I need to find 50, I'll make a for loop that's like for I is less equal to 0, I is less than 50, I plus plus. and then we'll be like, well, I think there's like some random function out there, so I'll be like index is math.random between 0 and 50, and they'll be like, well, my string is some kind of empty string, and then each time I loop through it, I'll be like string plus equals my like, you know, chars by my random index, and then I'll be like, yep, that's my function, written a random function. That probably won't exactly work. I probably missed something there, but that's like one way to do it. And it might feel simple. You might feel like, okay, yeah, it was pretty simple. I just had that in one line. I've used math.random. You could probably, I don't know if you could simplify that further. Or you could say npm random string generator, right? There's a library called random string. And then you kind of look through the docs and you're like, oh, this looks pretty promising. And then you look through it more and you're like, oh, there you go, alphabetic, length 12. It looks like just letters, lowercase and uppercase. Oh, there we go. Nice and simple. Now you'd be like, well, I'll go and, you know, import random string from the random string library, random string.generate, and I've got my random string. These are great because you know what's lovely about this library? 500,000 people try and download it a week. Okay, that means there's usually a pretty sure chance that it's going to work because a lot of people maintain it. A lot of people look at it. The entire world can go and look at this person's code. I don't know where exactly it would be in here. Lib random string. This is the library, it looks like. This is the whole file. They themselves use a library called random bytes. Let's go check it out. Random bytes. What is random bytes? So interesting. It imports from the crypto library. This is a strange library. This is literally just reading from what's already in Node.js. I don't know why they do that, but it's probably a good reason. And charset, which is what, a bunch of characters that they've hard-coded, looks like. Numbers, chars lower, chars upper. Oh, I love this one. See? One source of truth. There's the letters. They're like uppercase is just the uppercase version of the lowercase ones. So that's all the code they've written. That and the one we saw before. And that's the whole library that does everything we want to, which is great. And we could just use that instead. So keep it simple. We can look at some code examples, but honestly, the majority of keeping it simple that I ever see is like, has this been done before? It's a really great question. It's always like, are you uniquely the first person that's ever had this problem? Sometimes the answer is yes. I have the answer to that. The answer to that question for me is yes, maybe once a year. You know, there'll be something really obscure that I'm trying to do. The library that powers these slide decks is like, I tried to do a thing and no one had ever done it before, and I was like, okay, this is like one particular thing. But like that rarely happens. So you know, another one, write a function that prints the day of the week. Don't need to do this one because we did it back in week 3, I think it was, where we did the date functions library when we talked about, or was that Uchao? Did you do that with Uchao? Uchao, that's right. Another one, write a program that takes in a command line argument. Oh, this one's so interesting because I actually started doing this one. This is an old slide, but I was writing this tool for tutors to use, and I was like, man, I'd love a way to like, they could like run the program and it would give them like prompts and they could like, you know, choose options on the terminal. And I was thinking about how would that work? Would you have to like console log to the terminal and then you'd be like, you do like a prompt function and be like, read it in. And there's an old library, there's an old thing I tried to write years ago where like you would print something to the terminal, be like option A, B, C. And I thought I was really smart because I was like, well, options is like, you know, get started, pause, cancel. And I'd be like, well, what I'm going to do is say console log. Actually, I literally was like, aren't I smart? Options.map console.log. Give it like, that's literally a cheeky way of just saying print out everything on the terminal, right? Because you're mapping over each of the elements. So I was like, print it out on the terminal. Then I'd be like, prompt function, what one do you want? And maybe I'd like have this be like a 1 or something and a 2 and a 3. And then you'd be like, well, when you get the input, then you say like, well, if input dot includes a 1, then we're going to go do 1 stuff. Else, if it includes a 2, we're going to go do 2 stuff. This would be like trying to write your own library. And you might be writing it in a fairly simple way. But again, if I look at I can't remember what it's called. Node.js terminal command input. Read line, that wasn't it. What was it called? Let me think. Terminal library. There's probably a lot of them. I don't remember what it was called, but Node.js prompt library. Maybe this is it. Prompt, maybe it's called prompt. Maybe it's this library. But there's basically like, there'll be these libraries out there. I don't think they're giving some good examples. Is there like a demo example? I don't know. Let me quickly find it. I don't want to kind of like ruin this one. I don't know where it is. That's okay. Node.js, was it CLI? Oh, that might be what I want, CLI library. CLI is like command line interface. Can't believe I forgot what it's called. But they'll basically be like a CLI input list library, npm CLI select. It might be something like this. There's so many of them. I found a good one the other day, but you'll typically go and tell it like what can someone enter on the command line, and then when they call it, see the examples. Nah, it's not really that useful. Let me show you what I mean. I'm being stubborn now. Yeah, like this. So see this little thing here? It's like, which course are you doing stuff from? And you like go and select them, and then you select that course, and it's like, what's the iteration you're working with? So all this stuff here, like all this like interactive, like that's me using the arrow keys up and down. That's just like all part of the library. I just like gave it a list, and it just does that for me. So if you ever want to write a little node program where you want to let people input options and get different stuff, you can just do this. It's probably like 20 lines of code. And what it ends up with is basically a couple of functions where then I'm like, okay, I have all your inputs now, I can run stuff. So really powerful things. I'm sorry that one dragged on for a few minutes while I was kind of clamoring around for stuff. The rest of the stuff's pretty easy. Is this over-designed or under-designed? This one is so hard to do. Like, is it simple and is there one source of truth is a pretty easy thing to see, even very early on. Is it over-designed or under-designed? I wouldn't expect most of you to really have a good grasp on this one yet, just because you probably haven't written a lot of software. But under-engineering and over-engineering are both respective problems. You can waste a lot of time when you're writing code trying to plan for the future, right? They might call that future-proofing. You'll be like, well, we might need exceptions in the future. And what happens if our system is not just going to run quizzes, but it's also going to, have Instagram photos on it? And what if there's going to be like an AI chatbot in it? Like you can kind of go crazy. And in some ways, that part of you is a good part of you that's trying to plan. And that part of you comes out of the part of you that wants to do good software design by being like ready for the future. Because what is readiness for the future? It's like making sure your software is maintainable so it can change. So if you're thinking about how can my software change over time, that's really good. But there's a sweet spot where like if under engineering it makes sense is when you don't care about the future, so you just do it for now. But if you over-engineer it to the point where like you have an app that is like ready for something that's never going to happen, you've created a really big complex thing that as people try and use it, just for like little aims, they're not going to be able to really figure it out. The way I see this come up a lot with people's coding is they go and create like layers and layers and layers of functions for like really simple applications. Like something like your project only needs to be 5 files. I've seen students and tutors make your project using like 50 different files. They'll be like, here's a constants file, and here's a utility file, and here's like another file, and then there's a service layer, and they'll go make all these things because they're like, what if the project gets really big or it's very capable? But if it never gets there, like if you're like, okay, we have an easy spec now, I'm going to prepare it for hard in the future, but it never gets that big, all you're going to do is like screw the people over who are trying to make a medium complexity thing because they're going to be battling all these complicated systems along the way. For example, sometimes repeating yourself twice is okay. Some people might try and abstract absolutely everything away to the point where it's hard to read. That's kind of what I was saying earlier when we had this example and we were like abstracting away process.exit and repeating ourselves that way. Sometimes that can be a little bit cooked. I won't talk about some of those things. I'm pretty sure if anyone wants to go deeper in some of these, I've done this kind of lecture before and it's probably up on YouTube somewhere. This one is also not really a lot to elaborate on. Related modules kept close together and unrelated modules kept far apart. You'll see this often referred to in a software design sense as coupling and cohesion, and there's some big kind of words to do with that. But the way I like to think about it, it's actually really simple again. If you have two functions, if they do a very similar thing or they relate to the same topic, they should be really physically close together in the code. Maybe in the same part of the file, maybe in the same file, maybe in different files in the same folder. And if you have things that do unrelated things, they should be very far apart as a general rule. And I think it's a great thing you can apply to your project because you can look at it and say, okay, in my auth.js function, I've written a helper function. Does that helper function specifically solve a problem related to auth? Maybe all it does is validate an email. Validating an email is not something specific to logging in and logging out. So take that function and put it in another file. If they're not related, separate them out. If they are related, keep them close together. Some of you have probably got code in your project where you've written a helper function in one file that's only used in another file, and it's well, go and take that out of the helper file and put it back in the file. What's the point of a 100-line auth.js or TS file where you've written helper functions that are only used in that file and putting them somewhere else to just confuse someone who's now got to go and hunt through other files? A couple of last things. I'll move quick, so don't get too restless. Am I speculating about how necessary this is? This one actually ties really closely to the under-engineering aspect of things. It's really easy when we write code to be like, where's this going to go in the future? So think of this like the 3 and 4 one. I talk to my engineers all the time because they'll say to me something like, oh, should I do this in case this happens? And I'll usually just ask them, how sure are you that it's going to happen? If you think it's a reasonable chance, then yeah, prepare for it. If you're not too sure, if it's maybe, then it's we'll deal with it later. Because it's just a cost-benefit trade-off, right? If making your code ready for changes adds 20% time to it, then you need to generally be more than 20% aware, you think it's more than 20% likely to happen, There's no point kind of investing 20% of your time everywhere to make your code super ready for changes in the future if there's a 1% chance that it's going to happen. Is Netflix ever going to sell books? Probably not. So they probably don't spend a lot of time getting their code ready just in case it becomes an e-commerce store. They just bake it in. They're it's a movie, it's a TV site. I'm sure when they started off selling movies, they might have thought we might be making TV shows in the future. That seems like it might make sense, so let's consider that. Let's consider the system setting it up that if there's a piece of media, that there might be episodes here and not just a movie. There'll be stuff like that we have to consider as well. There's a couple of examples we could go through. Again, we could go look at old lectures. The exceptions lecture ran a bit longer than normal. The last one here I wanted to talk about is, does this follow standard conventions? This one's really, really important. Sometimes you can write simple code that's weird code. Don't write weird code. Weird code is code that a typical person with your professional background wouldn't follow or understand. What I mean by that is if you're going to go use a library, go use a library that people have seen before, probably, or understand. A good example of that's this whole print thing, the example I gave here. You wouldn't do that because people know what console log is, but they don't know what print is. So you're just going to confuse them because there's so much power when you write code. And again, it's hard to see probably this early on. And when you write code and other people come to it, they bring a huge amount of preconception about it. They know what console logs are, they know what variables are, they know what functions are and camel case are. So don't go and create all kinds of crazy, weird systems that don't make sense to normal people. Leverage what everyone already knows about stuff before. Even a good example is Jest. You can configure Jest to run on Jest runs on .test.ts or .test.js files, right? However, you can configure Jest to run on a different kind of pattern. Maybe you want a file called some file .testingmycode.js. You can do that, but why would you do that? Because there's going to be hundreds or thousands of developers out there that understand that a .test.ts file means it's a test file. And all you're doing is hampering yourself by like removing all of that knowledge they bring to it. Because whenever someone tries to understand your code that they haven't seen, there's a gap they don't have to bridge because they know what a lot of this stuff means. So that's what you've got to try and tap into. Anyway, sorry that some of that got rushed through. Hope it was interesting. People have been asking, do we get marked on maintainability? You'll have to consult the project spec or post on the forum. I know you get marked on your code quality. That's kind of true. These are more tips. So I'd say that you're always marked on the quality of your code, but your tutors will amp that up throughout term. And these are kind of tips about how to approach it and how to have discussions with your group. So check that out. I'm away in week 7 for work, so I will be doing 1 lecture in week 7 online. Yuchao will talk about that. Otherwise, I'll see you probably in week 9 otherwise. So